Good morning, students. My name is Abhishek Sachdeva, Lalpur Khalsa College of Engineering, Department of Civil Engineering. And students, this is the lecture for civil engineering students, fourth semester, and the subject is concrete technology. So, students, earlier we have discussed the compressive strength of the concrete, and in this video, we are going to discuss the tensile strength, that is the split tensile strength of concrete. So, students, basically, if we are talking about the compressive strength, split tensile strength, or the flexural strength of the concrete, so basically, they are the strength properties of the concrete or the mechanical properties of the concrete. Concrete, it is having the mechanical properties, or it may be having the durability properties. So by this compressive strength, split tensile strength, and flexural strength, we are basically evaluating the mechanical properties of the concrete, right? So the one of the major important mechanical property of the concrete is split tensile strength. So tensile strength is one of the basic and important properties of concrete. A knowledge of its value is required for the design of concrete structural element. Its value is also used in the design of pre-stressed concrete structures, liquid retaining structures, roadways, and runway slabs. So the split tensile value is very much important in the designing of these structures, retaining structures and roadways which are having the strength, which are retaining, which are adjusting the loads, and based upon the split tensile of the concrete, the design elements, the structural design elements, they are taken into the consideration. So the tensile strength is important property of the concrete. So the concrete, moreover, it is very weak in tension due to its brittle nature, right? So it is not expected to resist the direct tension, so concrete develops cracks when tensile forces exceed its tensile strength. Students, why this basically test is considered as important factor? Because the concrete is very weak in tension due to its brittle nature. Hence, it is not expected to resist the direct tension. Concrete develops cracks when tensile forces exceed its tensile strength. Therefore, it is necessary to determine the tensile strength of concrete to determine the load at which the concrete members may crack. So that is why it becomes an important property, right? The direct tensile strength of concrete is difficult to determine. Resource is often taken to determination of the flexural strength or the split tensile strength and computing the direct tensile. So what is split tensile strength test? As I had explained, a method of determining the tensile, a method of determining the tensile strength of concrete using a cylinder which splits across the vertical diameter. Students, basically the sample is basically cylindrical in nature. So a method of determining the split tensile strength of concrete using a cylinder which splits across the vertical diameter. It is an indirect method of testing tensile strength of concrete. Now the specimen, students, when we are performing the split tensile strength, so basically split tensile strength test on concrete cylinder is a method to determine the split tensile or the tensile strength of the concrete, and the procedure is based on ASTM C496, that is standard test method of cylindrical concrete specimen, which similar to other codes like IS 58161999. So according to the procedure which is mentioned in the ISTM C496, which is your standard test method of cylindrical concrete specimen. that is being taken into the consideration, and as per the specimen detail for routine testing and comparison of results, unless otherwise specified, the specimens shall be cylinder 150 mm in diameter and 300 mm long. So now, how this test is performed, right? What are the apparatuses which are used? What are the equipments which are taken into the consideration while performing the split tensile strength? So it includes the testing machine. Testing machine shall meet the requirements which are also given in the specified code. It shall be conforming to the requirements of test method C39/C 39M. Testing machine should be able to apply the load continuously and without shocks. It should be able to apply loads at constant rate within the range of 0.7 to 1.4 MPa per minute, 1.2 to 2.4 MPa per minute, based on IS 5816-1999. So split tensile strength, it is having certain specifications which are related to the testing machine, which are given in the concerned IS code. Furthermore, students, we can test this particular sample in the same machine which is used for the compression testing machine. So this is the arrangement for the split tensile strength machine. Then plate or supplementary bearing bar, that is essential. It is employed when the diameter of the largest dimension of the upper bearing face or lower bearing block is less than the length of the cylinder to be tested, and the plate width is kept as 50 mm. So it shall be used in such manner that the load will be applied over the entire length of the specimen. When the specimen it is placed under the in the testing machine, or the compression testing machine, or the split tensile testing machine, it shall be used in such a manner. It should be placed in such a manner that the load will be applied over the entire length of the cylindrical specimen. So the bearing stripes, two bearing straps are used. Bearing stripe size of 3.2 mm thick and 25 mm wide bearing strip is used, and the bearing strip placed between the specimen and both the upper and the lower bearing blocks of the testing machine, or between the specimen and supplement bar or plates if needed, is required and placed along with the sample. So this is the basically the equipment or the apparatus which are used, and apart from this, the weights and the weighing devices, tools, containers, and pans for carrying material and mixing. As we have considered this in the compression testing test also, the equipment is required. So testing machine and the circular cross sectional rod for tamping and three cylinders. Students, cylindrical specimen we have to manufacture, so we need to have the three cylinders at least for filling up the concrete and for testing in the testing machine. So, concrete specimen molds, it shall be made of steel and 3 mm thick. The mold shall be capable of being opened longitudinally to facilitate the removal of specimen, and is provided with a means of keeping it closed while in use. The mean internal diameter of the mold is 15 centimeter and the height is 30 centimeter. The molds are provided with the metal base plate, and molds need to be coated with a thin film of mold oil before use in order to prevent adhesion of concrete. It is very important factor, very important parameter, that when we are going to fill the mold with the concrete, either it is the cubical mold or it is the cylindrical mold for the split tensile strength test, it need to be greased. It need to be oiled properly from inside, so that sticking of material with the plates of the molds, they may be avoided. So these are the various apparatuses which are considered in this test. Six, a jig for aligning concrete cylinder. This is basically the cylindrical specimen which you are viewing. So these types of specimens have to be casted and tested for split tensile strength. Students, stamping rod, it is having also having certain specifications which is used for the manual compaction of the concrete specimen. It shall be round, straight steel rod with at least the tamping ends rounded to a hemispherical tip of the same diameter as the rod, and both ends they are rounded, and the diameter is 16 mm and the length is 600 mm. So basically it is required, it is used to compact the concrete, as when we are filling up the cylindrical mold, it is filled in layers. So tamping is required with the tamping rod. Then concrete pouring and compaction. So we have discussed the apparatuses, the general procedure of this test. Now students, when the mixture is prepared, it is poured into the oiled mold in layers approximately 5 centimeter deep, as I have explained you. Then each layer is compacted either by hand or by vibrations. So how the sampling is done? Basically we are discussing the sampling. After the mixture is prepared, it is poured into the oiled mold in layers, and then each layer is compacted either by hand or by vibration. For manual compaction, tamping rod is used. Otherwise, you can place your specimen or your mold on the vibrating plate, and the concrete in the molds it may be filled by placing the mold on the vibrating plate. But when we are not using the vibrating plate, then it needs to be manual, and the tamping is to be done with the help of the tamping rod for the compaction. So distributed bar stroke uniformly when you are using the tamping rod in order to compact it properly, and minimum tamping bar stroke for each layer is 30 numbers. Penetrate strike into the underlying layer, apply the rod for the entire depth of the bottom layer. Then students, after that, this is basically the sampling, right? Then preparation of the material, that I have also explained you. Then weighing and then mixing of the concrete. After mixing of the concrete, the molds they are filled up, and the molds they are filled up which are of the dimension 150 mm diameter and 300 mm in height. And similar, the mold and the base plate shall be coated with a film of mold oil before use, as I have explained you. And the curing specimen, if we are discussing the curing specimen, the casted specimen should be stored in a place at the temperature of 27 degree plus minus 2 degrees Celsius as per the Indian standards for the time addition of water to the dry ingredients. After that, the specimen should be marked and removed from the mold and be immediately submerged in clean fresh water or saturated lime solution and kept there until taken out just prior to the test. The water or the solution to which the specimens are kept should be renewed every 7 days and should be maintained at a temperature of 27 degree plus minus 2 degrees Celsius. And for design purpose, the specimen cured for 28 days shall be kept under the observations. So this is basically how the molds they are placed, the molds they are prepared, and after that they are ready, they are made ready for placing into the testing machine and getting the results. So if we are going through the step by step procedure, then prepare three cylindrical concrete specimens, right? Initially take the wet specimen from the water after 28 days of curing. After taking it from out of the water, the samples they are wiped off, and then after that draw diametrical lines on the two ends of the specimen to ensure that they are on the same axial plate. And this basically is the important parameter of drawing the diametrical lines on the two ends of the specimen. Record the weight and dimension of the specimen. Weight and dimension needs to be recorded, right? Then place plywood strips on the lower plate and place the specimens. So Two strips of nominal thick plywood, free of imperfections, approximately 25 mm wide and of length equal to or slightly longer than that of the specimen, should be provided for each specimen. The bearing stripes are placed between the specimen and both upper and lower bearing blocks of the testing machine. They are observed. Then bring down the upper plate so that it just touches the plywood stripe. Apply the load continuously without shock at rate within the range of 0.7 to 1.4 megapascal per minute as per the IS code, or 1.2 to 2.4 megapascal per minute based on IS 5816-1999. So the load shall be applied without shock and increased continuously at the nominal rate within the range of 1.2 megapascal per minute to 2.4 megapascal per minute. Record the maximum applied load indicated by the testing machine at failure and note the type of the failure and appearance of the fracture. Record the maximum applied load which will be given by the testing machine. We have to note down the failure load, the maximum load which the concrete specimen has taken, and the that load is noted down, and the breaking load is noted. So what is the calculation for this calculation? It will be how the split tensile strength is calculated for the specimen. This is the formula for that. T, it is equal to 2p upon pi LD, where T stands for the split tensile strength, right? And P, maximum applied load indicated by the testing machine. Maximum applied load, which will be your the failure load, breaking load, that will be the P, which will be given by the reading of the testing machine. So breaking load is your P value, that is the maximum load which has been taken by the concrete specimen, and L, it is the length of the specimen, and D, it is the diameter in meters. So you need to take care about the various units while putting the values in the equation. And the split tensile strength, it can be calculated by T equal to 2p upon pi LD. So this will give us the split tensile strength. So result, it is found that the split tensile strength is closer to the true tensile strength of concrete. It gives about 5 to 12% higher value than the direct tensile strength test. So this is the observation, right? Advantages of using this method. Advantages, it may be considered as the same type and the same specimen can also be used for compression test that I have explained you. Same type and same specimen, they can be used, and it is simpler to perform and gives uniform results than the other tension test like ring tension test and double punch test. Students, this test is easier also to perform, and it can be easily the specimen can be easily created. It can be easily tested in the testing machine, and it is easier to obtain the results by this method, by this procedure. Otherwise, if we are talking about the ring tension test and the double punch test, they are somehow more laborious as compared to this split tensile strength. Laborious methods, they are basically the laborious methods. So this is the split tensile strength test for concrete. Students, thank you.